Now, theorem 5.4, angle bisector theorem. It says that here, that if you have angle, its name is PQR, and there's an line, or there's a, you can say ray, that's cut this angle into two equal halves. It makes this part equal, or this angle equals this angle. Then, if this, from this point S, you draw a line, and this line is perpendicular on the side QP, and from S, you draw a line that is perpendicular on QR. So if the angle is bisect, or if the line bisect the angle, the line bisect the angle, we call it angle bisector. And from the point S, or this point is have an perpendicular, or from the point S, I draw a line that is perpendicular on QP, and there's a line that is perpendicular on QR. If they are perpendicular, so I can conclude that SP, this line here, is equal to this line. So let's repeat it here in other letters. That, as an example, you have a angle A, B, and C. And there's an angle bisector. Angle bisector means there's an bisector that's cut the angle from its name. Angle bisector means it's cut the angle. And there's a point, let's name it D, on this bisector. If you draw a line now from point D to C, and this will be a perpendicular on it, and if you draw another one that is perpendicular on BA, so if DC is perpendicular, DC is perpendicular on BC, and if DA is perpendicular on BA, this line and this line, if they are perpendicular, so that's mean the length of DC will be equal the length of DA. This is here our theorem of the angle bisector theorem. Is it clear?
Miss, how DC is perpendicular to BC? Like each one is moving in a way.
DC, this is DC. And this is BC. It's not
perpendicular, not parallel. Yes.
They are perpendicular, yeah.
Okay, Miss.
Is it clear?
Yes, Miss.
Yes, Miss.
Now, converse of the angle bisector theorem says that if you have an angle, any angle, P, Q, and R, and in this angle, there's a point. This point is here. And the distance from this point up to this line and from this point up to this line are equal. So if there's a point S here, that the point that is interior in the angle, it is inside the angle, and you draw a line from this point up to the line QR, and there's a line, you draw it from this point up to the line QP, and after you draw them, you find that they are equal. Since they are equal distance, they are equal in distance here, so that's mean if you draw a bisector from S to Q, it will bisect the angle. I will repeat it now. If there's a point S that is interior of an angle. It is inside the angle. And this line, if you draw a line from point S to this side and from point S to the other side, and they are equal, you draw them, they find that they are equal in distance, equal distance. So that's mean if you draw a bisector starting from this point S, cutting this angle, it makes them equal, and we call them angle bisector. Is it clear?
Yes, teacher.
Yes, teacher.
Okay. Let's solve now this example here. Determine whether angle A, point A, interior point A, must be on the bisector of the angle TXR. Explain. Now, how can I determine that if point A is on the bisector or no? I told you from the converse of the theorem that if I have this angle and there's a point that is an interior point of the angle, and if you draw two lines and these two lines are equal distance from the sides of the angle, if they are equal distance, so if I draw, so the bisector that cut the angle must be pass from this point. I must pass from this point. So how can I know now if point A is in the bisector or no? I will see if this distance from this point up to the side of the angle, is it equal to the point or to the equal to the line from that point to the second angle or to the second side? If they are yes equal, so I will say yes, the bisector passing from this point. Let's see here these examples. Here now we have angle point A. And I told you that if I want to determine that if these two angles are equal, or if this point are on the bisector or no, what do they must have?
Teacher, they are not equal.
They are not equal. So can I say that point A is on the bisector?
No.
No, bravo. So since point A here is the distance from Q or TA as not equal to ARA, so that's mean since they are not equal distance, so that's mean point A will not be on the bisector of AX. Okay. So let's write it here now. Let's write the answer now.
Miss, I wrote since TA is not equal to RA, so point A will not be at the point at the bisector. I mean.
So let's write it as number 29 here. That's, you will say no, because A is not equal distance from the size of the angle TXR. So they are not equal distant from the side. So we cannot say that point A is on the bisector. Fine. Number 30 now. In number 30 here, we have an angle A, and this angle A, it's cut the angles here, this bisector A, it's cut the angles into two equal angles. Can I say that angle A is on the bisector?
Yes, teacher, it's the bisector.
Yes, bravo. So
Yes,
I will say
because
yes.
it divides into equal Yes, يعني.
أيوة برافو. It cut it into two equal angles. So the markings here show that the angle TXA is equal to the angle RXA. TXA, this angle here, is equal to the angle A or RXA. So because of that, we can conclude that XA is the bisector of angle TXR. So I will repeat, in number 29 here, yes, they make them have an equal distance. Equal distance means, they didn't make them as an equal distance. So since they don't have an equal distance, so they are not, they will not be an angle bisector. The second one, angle here, yes, it cut the angle into two equal halves. So yes, it will be an angle bisector. Now let's see number 31. In number 31 here, we have an angle A, and they are perpendicular on the sides of the angle, and cut them, the distance, sorry, from A to R is equal to the distance from A to T. So can I say yes or no?
Yes, miss, because
Yes,
it's
teacher,
given
yes.
that RA is equal to 80.
Yeah, so and point A is an equal. So they are equidistant from the sides of the angle TXR. So if I can say that this is an angle bisector or no, it must classify, or we can say it must accomplish one of three things. The first one, it must be perpendicular on the sides of the angle. It must be equidistant from the side of the angle, and it must be cut the angle into two equal halves. If these three things accomplished, I can say that this is an angle bisector. Is it clear?
Yes,
Yes.
teacher.
Now, let's go back here to the perpendicular bisector. When can I say that this will be a perpendicular bisector? In two things. The first one, if it is perpendicular on the line and cut it into two equal halves, so this will be a perpendicular bisector. Or if there's a point that is parallel to this side and they have an equidistance from the endpoints of the line, so they will be a perpendicular bisector. So for the perpendicular bisector, they must be perpendicular on the line, cut it into two equal halves, and the line from that point to the end points of the line must be equal. If this one of them happen, so I can say yes, this will be a perpendicular bisector. Now for the angle bisector, as I told you, they must be an equidistance from the sides of the angles, they must be perpendicular on them, and they must be have an cut the angle into two equal halves. Now let's solve problem number 3 here. Now, what is the length of Rm? Now look at here. Here we have Rn. Rn is an perpendicular or is an angle per bisector. Is it right? Can I say that Rn is an angle bisector?
Yes, miss, because
Oh yes.
and the angles are proved
So
here.
since they cut it's cut, you can say. Just a minute. It cut the angle L and Q into two equal angles, and angle of M and R is equal to the angle of R and P. So since they are equal, so I can say yes, they are angle bisector. But since they are angle bisector, so means they will be perpendicular on the sides of the angle, as you see here. And since it is perpendicular on the sides of the angle, so they are equidistant from these sides. It means like the side or the length of this side will be equal to the length of this side. Is it right?
Yes, Miss.
So since they are equal, so I can say that 7x is equal to 2x plus 25. 2x plus 25 is the length of the second side, and 7x is the length of the first side. Since they are equal, I can find now 2x. I can find, sorry, x. So 5x is 25. So what's the value of x? It's 5. Now, what did he need to find? Did they ask me to find x?
No, they asked to find the length of RM.
Bravo. They asked me to find RM. So the length of RM will be 7x. And since I found it,
5.
so I will say it's 25.
35.
Sorry, 35.
Yes.
Is it clear?
Yes, Miss.
The other
Yes, teacher.
Is it clear? Okay.
Yes.
Now here, yeah, other example. Cut it to 3. The length, now see here, CF is an angle bisector that cuts the angle BCD, as you see here. It cut it into 2 equal halves. Since it cut it, so the distance from point F to the line, which is perpendicular on the sides of the angle, will be equal. So this side, FP, will equal to FD from our theorem, which is 5, 2. So then, since they are equal now, so it means like 6x plus 3, the length of FP, will be equal to the 4x plus 9. So minus 4x, so 2x plus 3 is 9. So minus 3, so 2x will be 6, and x will be 3. Now, what did he ask me? He asked me to find the length of FB. Where is FB? What is the length of FB?
6x plus 3. She's going to be
6s plus 3. And I know the value of x, so I can say 6 times 3 plus 3. 18 plus 3 is 21.
21.
Is it clear?
Yes, teacher.
Miss, so it's 18 plus, yes, it's clear, Miss.
Okay.
Yes.
Now, use the figure at the right for exercises 12 to 15. According to the diagram, how far is L from HK, from HF? Yeah, the first one, let's start them. Let's start solving them one by one. Now, here, as you see, LH is an angle bisector of the angle KHF. Since it is an angle bisector, so it's cut the angles into 2 equal halves. And it has an equidistance from the sides of the angle. Now, according to the diagram, how far is L from HK? how far is L from HK? Yes, Granette. This is HK. How far? What is the distance between point L to the line HK?
Six y equals 4y plus 18.
No, wait. I told you how far is point L from the line HK?
Point L, teacher, or K?
27.
Teacher, it's
27.
27.
Bravo. So, how far is L from HK? It is 27. Can name it like A and B here. So, LA is 27. Now, what about the distance from L to HF, which is LB? What is the length of LB will be?
27.
Teacher, yes,
27. Bravo. So the distance from point L to the side of the angle is 27. And the distance from point L to the side of the second, or to the second side of the angle will be 27 too. Okay, this is number 12. Number 13 now. How is HL related to the angle KHF? How it's related?
Oh, it bisects it. Bisector.
So yes,
Bisect.
HL bisects the angle KHF.
KF.
And point L is equidistant from the sides of the angle. Now, number 14. Find the value of y. And number 13. Since h or LH is an equidistance from the sides of the angle and perpendicular on them, so I will say that it will be an angle bisector from the converse of the theorem. Now, number 14. What is the value of y? In number 13, we conclude that LH is an angle bisector. So if it is an angle bisector, can I say that 6y equal to 4y plus 18?
So 4y plus 18, yes.
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 Since it is an angle bisector, so it's cut it into two equal halves. So 2y will be 18. So y will be 9. So number 15 now. What is the measure of the angle KHL? Six y. So it will be 6 times 9, which is 54 degree. And what is the measure of the angle FHL?
4 times 9.
Teacher,
KHL, the angle.
It is
Yes, 6 times 4. 6 times 9, miss.
6 times 9, 54. So the
Yes.
FHL will be 54. Why? Because since it is an angle bisector, so it cuts the greater or the big angle, which is KHF, into two equal halves. So if I found the first one as 54, So
Yes.
the second one will be 54. So if this angle here is 54, here it will be 54. Another way, you can substitute y here. That is 4 times 9 plus 18. 36 plus 18 will be 54 degree 2. Is it clear?
Yes,
Yes,
Miss.
miss.
Clear.
Okay.
Yes.
Teacher, no, question number 12. You said Miss LA and LB. Yani,
Oh.
so LA. Teacher,
I from where I bring A and B, yani?
yes, Miss.
I name them in order to understand. I name this
Okay.
point. Yani I said like they are like this here. I name that this point is A and this point is B. Because when I asked you how far point L from the line, no one understand the question. I told you what is the length of LA, you told me it's 27.
Okay, Miss.
Okay. Do you have any question?
No, Miss. Thank you so much.
Okay.
No, miss.
Fine. Now, let's start with lesson 3. Now, please, I want you to focus with me. Lesson 3 and lesson 4 are very important. I will give you like an introduction of this lesson. Bisectors and triangle. Now, up to now, in the first 2 lessons, we talk about the mid-segments. In lesson 2, we talk about the angle bisector and the perpendicular bisector. Today now, we are going to talk about the bisector in triangles. The lesson 2, we talk about angle bisector. And it is a bisector cut the angle, or the bisector cut the line. Today, we are going to talk about the bisectors that cut the triangles. Which is it? So, which is it? An bisector in triangles. In this lesson now, we are going to identify the properties of the perpendicular bisector and angle bisector.